Welcome to Pravdan Tutorials. Please kindly subscribe. Thank you.
Everyone, and welcome once again. So today I'll be taking you through how to differentiate this type of function. Okay, and at the end of today's lesson, you should also know the difference between this, which we've done before, and the new one we are going to do today. So this is referred to as a natural exponential function, and this is referred to as a natural logarithm function. And they are both inverse to each other. We are going to take a look at some examples for better understanding. But then, how do we differentiate a natural logarithm function? So quickly, let's look at this. Let's say you have y to be a natural logarithm function of a particular function of x. Okay, then you should note that the differentiation of this dy dx is simply, you see the function here, the function of x. Okay, so you differentiate it. When you differentiate that function of x, let's write it as f prime of x, which means differentiating to 1 degree of the function x over divided by that exact function of x. It's as easy as that. So if you remember this, then you can easily get your answer for this type of differentiation. So in general, if you have, let's say, y equals ln of x, so with what we've just done now, your differentiation of y with respect to x is going to give you, just simply look at the function, is ordinary x. When you differentiate x, what do you have? 1 over the function x. So that is your answer. Is very easy. Okay, what if you have this y equals ln ax? In this case, x has a coefficient of more than 1, let's say 2, 3, 4. Whatever it is, your answer will still be your dy dx. Okay, let's look at it. If you differentiate ax, what will you get? With respect to x, you'll be left with a over the exact function ax. And if you look at this a can cancel this a, you are left with 1 over x. So this means regardless of the coefficient of x, what is beside x, be it 7x or 3x, you will still get 1 over x in its differentiation. Let's look at this. If you apply chain rule, for example, using y equals ln ax. Okay, by chain rule, you remember we can say let u be equals to the whole of this, so which is ax. Then what do we have? We have y to be equals to ln of u. Remember, when you differentiate u, in this case with respect to x, our answer is a. And when you differentiate this y with respect to u, in this case you get 1 over u, which is 1 over, replace your u back with ax. According to chain rule, multiply both. Now you have the y, the u, the x, multiply the y, the u. And this leaves you with a multiply 1 over ax. And you still get your 1 over x. Okay, so now that you understand this, you can use this to differentiate any of this type of natural logarithm function. You can pause the video and lay your hands on the following. They are very simple. So having done that, let's see if your answer is right. So the first question says we should differentiate y equals ln 5x. So if I'm to use the cover-up method, remember, I'm going to have my dy dx to be equals to, in the denominator you will have the 5x, and in the numerator you have the differentiation of 5x. So when I differentiate 5x, I'm going to be left with 5. So you have this, and your final answer is 1 over x. So for question 2, let's see. So my dy dx is going to be, if you look at this, you see that there is 7, which is a coefficient to the whole of length 5x. So the 7 will still be there. So you have the 7, okay, left with. Now your focus is on differentiation of length 5x. So when you differentiate length 5x, what do you get? You get 1 over x. So at the end of the day, your answer is 7 over x. And lastly, let's look at this. The same procedure. All you need to do is identify the function ln of what? Sine x. So the next thing I'm going to do is my differentiation of y with respect to x is going to be, I have in the denominator that function which is sine x, and what I'm going to have in the numerator is the differentiation of sine x. So if you check one of our video on how to differentiate sine x from first principle or using the general differentiation approach, the differentiation of sine x will give you cos x. And in trigonometry, the ratio of cos to sine will give you cotangent, which is cot x. So that's the answer. Alright guys, I wish you all the best and see you in our next video. Please kindly subscribe. Thank you.
Please kindly subscribe. Thank you.